Hi, my name is Aaron. I work on Mootools, and I work at a company called Cloudera, and I blog sometimes and write about things, yada, yada. I sent in a bunch of presentation options to JSConf, said I could talk about this, I could talk about that, I could talk about Mootools and a bunch of other things. And the talk that they said, like, hey, why don't you come talk about is this one I have called Programming to Patterns, which I've only given once or twice. And it's the kind of thing where I feel like after seeing a bunch of the talks so far at the conference that maybe the room outclasses the talk. Like, quick show of hands, and don't be shy. Who here considers themselves to be a JavaScript badass? No, come on. Right? Okay. All right. So maybe not then. But I do kind of feel like that the tenor of this talk is aimed a little bit more towards people who have been writing JavaScript for a while, but they feel like maybe they aren't quite getting some of it, or that they get that sinking feeling in the back of their head like, I've written this before. Why am I writing it again? I know there's a better way. And so that's what this kind of concept of programming to patterns is about. And so I'm going to start talking, but to the extent that I'm right, that you guys are ahead of this curve, then I want to kind of change the nature of the topic to be like, what can we as developers of frameworks and bloggers about this technology and the people at our respective places of business who are the ones who know about JavaScript do to help the people who are coming to JavaScript, which is in many ways kind of the gateway programming language that a lot of people are getting started with nowadays. How can we help them get past this hump? So if you're someone who recognizes that you were here, what I'm going to be talking about, years ago, and that you've gotten past it, that's the question I have for you. And if not, if you feel like this is giving you answers that you've been looking for, then let's talk about that. Okay, so without any further ado, what do I mean by patterns? The biggest thing that I see happen a lot in people who are okay at JavaScript, who are still kind of getting started or even have reached kind of an intermediate stage, is that they don't abstract away from the things that they're writing. They just get the page to work. And so the concept that I'm really talking about here with patterns is about abstracting away from the implementation that you're looking at on your screen and writing something somewhere else that you can test on its own and reuse, and then extend and build off of when you need it to be slightly different than the one you made yesterday. And so if you think about the code that you write at all times as being an API, it's your API. I put my phone down there, so I don't think that's me. So if you think about the code that you write as being an API for yourself, and that you're always writing for this third party, which happens to also be you, and you ask yourself, like, well, when I use other people's libraries and they're really well formed, they have great methods that make sense what they are just by looking at the name of the method, its verb, that kind of stuff, and you write your code that way, it's just going to be easier for you to consume it. But on top of that, if you think about it in those terms and pull them out of the context of the thing that you're trying to get working right now, you'll just end up with code that's easier for you to reuse when you end up on a page 3 days later that needs something really similar that's not quite the same. Another concept here is to write as small a thing as you can. This isn't really rocket science. If a lot of people who come to JavaScript are not CS grads. I'm not. I went to college for music. Thank you. Right, just making my point further. So a lot of people who come to building on the client side come from design backgrounds, or they have some light computer science stuff, but they don't necessarily have really hardcore CS chops. Writing a function that only does one thing is sometimes a revelation for people who come to this programming language from those paths. And the same thing is true for your components. You shouldn't have one giant thing that you instantiate that makes the whole page do 80 things. You should have 80 things that all work together when you instantiate them on one page. And then the last thing is to really kind of talk about, if you write code this way, it makes doing test-driven development a lot easier. And so instead of your website is the test, and if you change anything, you've got to go click around on the website and see if it works, you go write a test that validates that your one function that does one thing does that one thing. And then tomorrow, if you need to use that thing again and you need to change it a little bit to do a little bit more than what your original need was, you can validate that the original need still works because you have a test for it. So I'll give you an example. When I started writing code, JavaScript, well, this isn't true. A couple of years ago when I was writing JavaScript, I thought of, I have these things called classes. And that's a loose term I'll talk a little bit more about, but it's not really a class in the classical sense of programming. But these objects that I can instantiate, one's for date picker and one's for form validator, one's for tabs, whatever. And then I had this namespace that was just this hodgepodge of all these functions that I considered to be completely esoteric, and only my app could ever use this stuff. My application had this concept of apples and oranges that had nothing to do with these kind of reusable things, but and then I had an initialize function that I would put in my DOM ready statement, that go and make apples, go make oranges, go make lemons, whatever. And what happened is that this thing just keeps getting longer and longer and longer. And you start putting state about the page that you're on in there, oh, the user's looking at this, so I'm going to hide that thing, but I got to remember where it was or whatever. So you start shoving all those other variables in there, and then it turns into this monster. And then, oh yeah, this tends to get out of hand. I had to click for that. And the other option is that you're looking at the page, and you're like, oh, I want that input to be an autocomplete. So I'm going to write some code to make that happen. And you end up just, this example actually says I'm going to take a form. This is Mootools syntax, but it doesn't matter. This talk isn't about one framework or another, really. And actually, as I go through this talk, you'll see I've implemented most of my examples both in Mootools and Dojo to show that a lot of these concepts exist, and they aren't really about a framework. So anyway, this says, hey, go grab a form and add a submit event to it and stop it when the user submits the form, and then send it with Ajax and update some container. OK, I've got my Ajax form done. Go to the next page. This kind of logic is really tempting to just get the page to work. It's I've got a function. It does the stuff on this page. Next page. But then the next page needs one of these. And so you're like, oh, I'll just copy that one, or I'll write something similar. Maybe it's 2 weeks later, you've forgotten where this one is, and you're like, oh, it's faster to write it again than it is to go find it, that kind of thing. So the pros of developing like that is that writing the logic in the specific app is really fast. I mean, you can really bang out what you want to happen on the page and be happy with it. And DOM-focused code, is very tied into the HTML that's on the page. And if that HTML changes, this stuff doesn't work anymore. The other thing is that the test environment is the app. I hit reload, I see if it works. I write a little bit more code, I hit reload, I see if it works. I write a little more code, it works. Next page. And so that test environment being in the app just makes development feel like you're making a lot of progress. The cons to this is that it's much harder to maintain. Now if you need to make some change on your site to the way that something behaves, you got to kind of go find all the places where you did it. And if you find that it's really annoying. If you find that you did something that had a bug in it, you might be able to go fix it on that page, but you're not certain that you didn't do it somewhere else. A high percentage of the code you write is not reusable. All the code that you put in those DOM ready statements at the bottom of the top of the page or in line or whatever, it's that's where it lives. And if tomorrow you need that same pattern, you can't do it again. And the con, as much as it's a pro, it's a con that the test environment is the app. If you don't have some place where you can just go and say, run all the tests and tell me which ones failed, but instead you've got to have a list of all the places on the site where you do something, and then your QA team and you have to go click through all of those use cases, it doesn't scale. So what do you do? Well, first is get over the fact that JavaScript is a really powerful functional language, and get really comfortable with objects. They're both great. I'm not saying that you shouldn't be using JavaScript as a functional language. You should absolutely be using functions to pass around as variables and treat them as those first-class objects. But using objects to store the state of an instance of this form validator, or that date picker, or this autocompleter, and then you have 10 of them on the page, it doesn't matter. You're not trying to shove these state variables into some global object that represents your page. Some people think of this kind of thing as classes, and indeed a lot of frameworks even use that term, new class or class.create or whatever. They aren't. They're just objects that happen to inherit from other objects, and I'll talk a little bit more about that. And this is how JavaScript solves all these problems. JavaScript has a lot of ugly things in it, but the inheritance model and the object model that it has is really powerful. And if you tap into that and avoid some pitfalls, then you'll find that your code becomes this toolkit that you take with you. It's this thing you hand down to your kids when you give them the business or whatever. Most frameworks help you do this stuff. Not all of them. Some things are really designed for one thing. A CSS select engine is not doing this stuff for you. It's helping you select elements out of the document. But by and large, most of the development frameworks help you write code in a more structured and reusable manner. So that's why I'm going to give examples in more than one of them. So let's talk about classes. So here's Mootools' way it does it. We have this constructor function called class that we hand an object literal. And that's going to be the prototype for any human that we create. And this constructor function returns a new function. Now we have a function called human. And whenever we say, hey, new human, I get returned an object whose prototype is this one that I started out with. And so if I want to create a new one, I'll get Bob Ross. If I want to create a new one, we say, var Bob equals new human. Bob's energy is 1 because that's what the prototype gave it. And if I say Bob eat, now his energy is 2. This on itself isn't really all that revolutionary. If you write your code this way, though, you tend to start breaking up functionality into small methods that do one thing, and you have a place to put all the properties about this instance of that object. So if you have 2 humans on the page, you aren't trying to find a place to put them both, and you don't have these large objects that have this giant state in them. No, I have this little granular thing. This is a human. These are the properties he has. These are the methods that he has, and so on. And so then, this is Dojo's version. I'm not gonna spend a ton of time really going between them because the syntax here isn't really that different. You can see Dojo declare human. It takes an argument which is an inheritor, or not an inheritor, but an ancestor. But I'll get to that in a minute. And then the object is exactly the same. And then the constructor and the method call is the same. So this is not, you'll find other frameworks that do similar things to this. So let's talk a little bit about prototypes. Who here in the room, well, I don't want to ask that question because it makes me feel bad, but is everyone in the room like really comfortable with prototypes? Because I can zip through this. Okay, I see at least one head say no, so we all get to listen to it. That's okay, it's fun stuff. So we're going to deconstruct that previous example. When we said new human and we handed it an object literal, well, I'm going to declare this object to an actual variable here so that I can talk about it. So var human base is exactly the same properties that I talked about a second ago. We have this object, our prototype. That's amazing that worked. So then in Mootools or Dojo, we declare this new constructor called human. So we have this thing, it's a function. And when we call new human on that and we create Bob, same syntax for both of them, we now have Bob, which is an object. It's our instance. So if we look at Bob and ask about his energy property, what we'll find is that Bob actually doesn't have one. He's just an empty object whose prototype inherits from this human-based object we started with. So the way prototypical inheritance works is that if I say, if Bob energy equals 1, then do something, that's true. Because the first thing that happens is it discovers that Bob doesn't have a property, so it goes up its prototype chain, and so on. And this is how, for example, all of your arrays have a method called whatever. Like if you ask for an individual array's join method, it's not really there, it's on the prototype. If we look for Bob foo, it's undefined, and it returns undefined because neither the prototype nor Bob have a property called foo. If we assign a property to Bob, foo equals bar, and then we go look for it, we're not going to go up this prototype chain. We're going to stop the first time we find it. And that inheritance model can keep going. So if there's more than one ancestor up here and you look for a property, it goes looking for it until it finds the first one in the chain. And then if I call it Bob's eat method, you remember it said bob.energy equals eat plus 1, or bob.eat plus 1, or plus plus. Now that prototype chain has been broken because we are never changing this guy. All we're doing is assigning a new value here. And so that is how the prototype chain gets overwritten, is through assignment. And so one gotcha that you have to look out for is that if you deleted bob.energy and then asked what bob.energy is, it'll be 1 again. So now let's look at our human class a little bit. I've changed a little bit. Now we can actually name our guy, and energy is alive, stuff is still there. But let's say we want to create a new kind of human. So I've created this ninja class. This is, again, some Mootools syntax. You could accomplish all of this in vanilla JavaScript, of course, because Mootools itself is JavaScript. So now we hand an object literal to Ninja, and we give this pointer to our human constructor. And what we're saying is, hey, I'm going to give you an object that when I create an instance of Ninja, this object is going to be my prototype. But when I say it extends human, then I'm saying make human's object the prototype of Ninja. And what that means is that Ninja by default gets this isAlive value. And we're overriding the energy value equals 100, so now Ninjas are always 100. And then it has an attack method. It also has an eat method. Notice that also Mootools gives us this pointer to the parent's version of a method. So I can call parent name and age for our ninja, but I can also take some additional arguments here, like what side this ninja is on. So we create our Bob, we create our ninja. Our new ninja is, his side is evil. Nintendo is his name, and his age is unknown, because they're shifty like that. And then we can see he's alive, his name is Nintendo, and then we can say black ninja.attack Bob, and you can see that Bob never had a chance, because this is a live value gets set to false. So the concept here is that we've got this really simple granular pattern for creating this one thing that does its one job. And then we're going to create a subclass of that that has additional properties, and it can refer to the properties of this prototype, including its methods, before and after additional code. And if this were just one function that created a human object and gave it back to you, then you could only ever call it. Whereas now, if we wanted to, we can alter the way that we reference those other methods and inject new things around them. So one other way that you can mix in classes is where you have two disparate things that you want to have as properties that get added to a class. Instead of it being in the prototype chain, it's this, instead of it being a is-a relationship, a ninja is a human, it's more of a has-a relationship. A ninja has a sword kind of thing. So here we have our ninja object. Oh, sorry, I'm skipping ahead. This is the Dojo example. You'll see that, again, the code looks almost exactly the same. Instead of initialize, they call it constructor. And then, Ninja has this inherited instead of this parent. But other than that, it's the same. There's an arrow. You see the constructor. All of this code is exactly the same. So mix-ins. So now we have our human object. Same thing we had in the last slide. We're going to create this class called warrior. And warriors have this notion of, hey, they fight, right? So they have some energy. They have a tracker for how many enemies they defeated. And they have an attack method that says if their enemy has less energy than them, then they win. Now we can create a ninja class. And we can see it still extends human, which means that its prototype is this human object. But in Mootools, we have this implements property that takes an array of mix-ins, which says, when this ninja class is declared, go get the properties from warrior and add them to this thing. And as a result, now our ninja class has almost nothing in it. All it does is assign what side it's on and then call it parent. That's it. And then it has all of the properties from over here and there. And then we have a samurai class, and it doesn't even have a method because its side is always good because they're samurais. And its energy is 1,000, whereas ninjas, it starts out at 100 unless you declare something else. Anyway, the point is that like this mix-in functionality gives you still have this inheritance property going on. So both of these guys are humans. They're an is-a, right? But they has a relationship to this warrior concept. Now this is all abstract. It's not really talking about like the actual DOM, like what you would do if you were developing something for an actual website. Of course, I have my Dojo slides. Sorry, when I originally wrote this, I didn't have the Dojo slides, and I didn't want it to be just about one framework. So you can see the syntax here. Again, looks almost exactly the same. The difference is that when in Dojo, we pass along this array object as its second argument, and the first one is what it inherits from, and any subsequent ones get mixed in. But otherwise the same. So let's talk about when we actually sit down to do some work. You know, you have a web page in front of you, and you need to write some code. And maybe it's tempting to write that DOM-ready statement, or just to put it in this global namespace object to have a function that says, make form Ajaxy. Let's say that you have a page full of search results that are interactive in some way. You can click on this input here and rename it, or you can click the X to remove it from the results. And there's tabs, and maybe you can click the image to zoom it or whatever. The trick is to think of each of these components as individual granular things. Go write a class that just does this, and go write another class that does your edit in place, and go write another one that zooms your image, and another one that knows how, when a DOM element is clicked, that it deletes another one from the page. And then you write another class that kind of strings all that stuff together. But that other class is not really that complicated. All it knows about is this DOM structure. Go find these elements and pass them to these constructors for the tabs, for the X, for the image, et cetera. And that high-level thing is probably something that you're going to throw away if you ever redesign the HTML on this page. But the low-level stuff, these tabs and edit in place and the image zoom and the X, like that stuff you could use pretty much anywhere. It's just tabs. So that design pattern is going to show up again. And if you start trying to think in these kind of granular patterns about how atomic can I make it, what you're going to find is that when you come to some other challenge a month later or a year later, that when half of these guys show up again, that they aren't tangled up in this thing. So some best practices to think of. One, shallow inheritance works best. I don't recommend getting so deep into the inheritance chain that you don't really know where a property is coming from. If you have 10 or 15 deep, you have this thing that inherits from that thing, and you're basically trying to recreate the origin of a species or something like that, you're going to be hard-pressed to know where to go fix that property or whatever. I would say, in my experience, that if you're more than 4 or 5 deep, then you're probably getting into trouble, and you need to think about ways to try and associate more functionality a little more shallowly. Break up logic into small methods. I've already said this, but you should really only have a function should be, well named, ideally a verb, and it should do one thing. And then the same thing is true for the classes. You should have a class that does one thing. That search result example, you have one called tabs, and that's all it does. And then when you have a larger thing that has a bunch of that stuff in it, you build this controller, and all it does is instantiate the smaller ones. If you think about it, this controller class is where things are brittle. The tabs functionality is something that isn't really going to change that much. Maybe tomorrow you have a project that needs to have tabs that fade instead of just switch immediately. And so you might go extend that tabs interface and add fading to it, or you might even just go edit the existing code that you have that manages tabs to add a fade option to it. But the general concept of what tabs do, that doesn't really change. But that search result page is definitely going to change as soon as the designer wants to change it. And so these controller classes are meant to have as small a footprint as possible, and all they really should do is know about their DOM. And in a way, your DOM-ready instruction should just kind of be one of these. And then you should use options and events liberally. I don't think I go into that really deeply in this talk, but the places where you want to extend these types of things is you want to be able to configure them in a multitude of ways. When I click on a different tab and it switches, maybe that's a function option that I can pass in that lets me decide whether it fades or it grows or whatever. When I click on the tab itself and it becomes the foreground, it gets assigned to some sort of class name. Maybe I can declare what that is instead of it being hard-coded in the class. It's got a default, but I can override it, that kind of thing. And so that's the sense of options. The events you really want to capture when anything asynchronous happens or anytime the user does something. So they click the tab. And when they click the tab, some event gets fired, which I can attach a function to so that whenever the user clicks a tab, I run something that shows the tooltips that were outside of that element or whatever. And then don't be afraid to refactor, but avoid breaking the interface. And if you're thinking about everything that you write in terms of an API, if you're like, oh, I'm going to make this thing so that I can use it generically, then in theory, you should get pretty good at writing APIs for yourself. And if you're good at that, then even if you need to go and completely rewrite the whole class, you can implement something that allows that API to still work, even with the class changes dramatically. And remember, if you've been writing tests well, then you still have a test that can run against that old API and verify that it's still there. So you don't have to go regress the entire website or sites that you manage. So let's take this a quick example here. I'm on time. Oh, good. So here I have my example that I started out with. It's a form with a submit event. And then on complete, I'm going to call this Ajax thing that updates some container in the document, right? Well, here's the Dojo version. It's a little more verbose, but Dojo is good for that because, good for them for namespacing. I've lost that argument with the Mootools guys. Anyway, so they have, Dojo query something, and then they have an onSubmit method that, hand a function that stops the event. It says, go get the target of the submit event, and then post that thing as an Ajax and update this Dojo by ID my container, set as enter HTML to response. Same thing. So this is the Mootools version. You'll note this is a lot more code. Like, wait a minute, the whole point of this is like maybe saving some time, right? What you're going to find when you start writing code like this is that you write a lot more stuff up front. You find yourself, instead of working your way down the page adding functionality, you're going to put this page that you're going to try and improve aside and go write a bunch of tools. You'll go write a tabs class. You'll go write a form class that submits for you with Ajax and stuff like that. You'll set it aside. You'll go write these things. You'll write a test that validates that those things work. And then you'll go back to your page and implement them. And this has an upfront cost. But the benefit is that the next time you need an Ajax form, you don't have to write that again. You just write one line, new form update, or whatever. So var form updater is a new class. I give it an object that's going to be our prototype. It has an initialize method that takes a form, the container we're going to update, and some options. I then store references to the form and the container, and then I create a new instance of Ajax in Mootools that's called request. And then I have a separate method called this attach. I could have just put this right there, but by having it as its own method, again, I have one method that does one thing. And then in the future, if I decide that I want to add more functionality by extending this is an extension point. I can have a subclass that has additional attachments that get made, and then it calls its parent. I have a send method. It takes an event, and if the event is defined, then it stops it. But it doesn't have to be there, so I can just call my instance.send, and it'll send the form, even if the user didn't click OK or whatever. This request.send, the form, onComplete, this onComplete, bind this. I'm not going to talk about binding, but it basically preserves what the pointer is to this instance. Again, I could have written a function right here that did my onComplete, but now because it's over here, again, I have an extension point where if I create a subclass that does something different onComplete, then I have an easy way to overwrite that. So onComplete function response text, this container set the HTML to the response text. Ideally, if I had more room in my slide, I would have also had some sort of event here, like this fire event on update or something like that. And then to instantiate it, new form updater, my form, my container. This line of code, that's the thing that's now in my DOM ready statement, or in my object that is my namespace for my website. And tomorrow, if I need it again, that's the only code I have to write. And if the next day something changes in here, I discover that this is a bug, I only have one place to fix it. The Dojo version, in the interest of time, I'm going to speed up a little bit. You can see it's very similar. It has the same methods. It does basically the same thing. It's just the syntax is different. But what happens if the next day we need something different? The pattern here is like a to-do list where you type in something new and you hit OK, and it just adds it. It keeps appending, and the input moves down the page as you keep adding stuff to it. Well, in that case, we don't want to overwrite the contents of the target that we're updating. We want to append to it. So here I create form updater.append, and here's a new class. It extends our form updater, so it has all the properties of that one, but I've overwritten the onComplete method. It does the same thing as the other one, except for it has an adopt method, which is a Mootools method that says append this text or DOM element. So I create a new element with a response text and put it inside the container. And again, my constructor here is essentially the same. It's just that I'm using the different class name. The Dojo code is equally small. And so now you've improved the functionality from your other class with only a little bit of extra code. And again, if there's a bug in your Ajax form stuff, you really only have one place to fix it. It's still over there. And if there's a bug in this adoption stuff, well, then you have only one place to fix that. So whereas previously I had this kind of concept where I thought of this as my application, and only these big concepts like date picker and form validator and effects as, oh, this is my reusable stuff. This stuff's not about my website. Now the way I write code is I write almost none of this. And I wrote almost all of that. Even if I feel like this class I will never use again, I can't count the number of times where like 3 days later I'm like, huh, I'm using it again. So the pros here is that you get this relatively reusable, readable, generic classes that you can easily maintain. Only the variables are managed in the specific application, which means that the footprint where you actually say new foo with this DOM structure is really small. And if that DOM structure changes, then you just go say new foo with that DOM structure. The code doesn't really care. I just made that point. The cons here is that it does require a bit more skill. Writing code this way, it's not really hard, but especially if you're just kind of like getting past the hump of learning how JavaScript works, and this stuff sounds in any way new to you, like it'll take some practice. The first couple of times you'll do it, 3 months will go by and you'll look at it and you'll be like, oh, I totally did that wrong. And then 3 months later you'll look at it and be like, yeah, I'm still doing it wrong. You know, now, like I've been doing this long enough where maybe my interval is 6 months before I hate what I wrote. But the point is that it does take a bit of practice and a bit of skill. It can often mean more bytes of code in the short term. That example I showed where the form validator class was actually bigger. But overall, if I use that thing in 8 different places, the amount of code that I'm writing is smaller. And if I'm using it in 8 different places with only minor tweaks, then I'm not rewriting it and delivering it to the user in a download. I've only delivered it once and then instantiated it 8 times. And then this test-driven development concept is really a must if you're going to develop this way, because you need to know that your stuff still works. And it works in the original version that you implemented as well as the one that you've just extended or whatever. And if this is something that's new to you, then that's going to be a struggle for you, because it just requires you to change your philosophy about how you work. So Mootools and Dojo and other frameworks help you do this. They make JavaScript easier. They give you these wrappers for functionality that JavaScript has kind of hidden. The same can be true of almost all of them, of almost all the frameworks. So this is not about just Mootools and Dojo. They encourage you to reuse your work and to write your code to be flexible for future use. Indeed, it gets kind of hard not to write code this way when you're using a framework that wants you to follow that development pattern. It just becomes much more natural for you to do it. And they themselves are designed to be extended. You know, I've written so many plugins for Mootools that extend a previous plugin that exists either by someone else or from the library. And by doing that, I'm making the library more suited towards my actual task. And these are really qualities of JavaScript. These are not things that you couldn't do without these frameworks. So that's the end of my talk. You can find more about Mootools and Dojo. I didn't check. Is it .org or .net? DojoToolkit.org? Yeah. My name's Aaron. I have this blog, clientside.com with a C, helping browsers do the honorable thing. I'm on Twitter as Anutron, and I work at Cloudera. We are hiring for JavaScript people if you are interested. So I'm done. I don't know how much time I have left, but if there's any questions, I got about 5 minutes, I think, right? So if there are any questions, by all means. There are many. To say what's like the best one is a way for me to get lynched. I'll tell you the ones I've used. The Mootools framework has used a couple of specs runners that run automated testing that will just basically run through a bunch of JavaScript tests and tell you which ones failed. The one that we've used the most is called JSSpec. JSSpec is the derivation of JSUnit, I think. I'm looking at Tom here. I'm wrong, yeah. JSSpec. We have another one that we are in the process of getting ready to release that's kind of an improvement on that. I've also seen a lot of other frameworks that are designed more for actual UI testing. So we use Windmill at work, which is a Python version of Selenium, which allows you to describe, put the mouse down and move it over and then lift the mouse up and then verify that this object just pixels are now 100 pixels less on the left or whatever. It's not quite the same as being able to say, did it look good? But it does let you do some integrated testing in that respect, and I highly recommend it. So both of those, as well as JS Unit and JS Spec.
Are you no longer using the testing you wrote?
So the thing that I wrote, which you can get in the Mootools repository, is basically a set of interactive tests that actually ask the question, does it look good? So I wanted a way to be able to test an effect and say, like, this was supposed to fade out over the course of 1 second. Did it? And did it look good? And so you could ask a question. Like, part of the test was that you actually asked a yes or no question for the user. And when they hit yes, it just ran the next test. Can you drag it? Can you double click it? Whatever. And that thing works great, but it was built inside of an iframe, and I need to rewrite it so that it's server-side oriented, because it's all written in JavaScript right now, which is popular these days to write everything in JavaScript. But anyway, the problem is that the iframe itself presents some problems, especially with offset computation and Internet Explorer, and so a lot of the tests were kind of broken because of the implementation of the test thing. It works pretty good. I'm gonna remake it so that it's the same exact thing except for it's page-oriented. Here's a farm. So I'm going to repeat what you had said just for those on the other side of the room. Because Mootools has an options pattern and Prototype has the same pattern in many of its classes, where the prototype object actually has an object called options that has all these defaults for the instance. You can easily subclass that original class and just define different options as the default. And now you have this kind of shortcut for creating a different default set of options for the instance that you want. So for example, you could have a date picker class that lets you choose whether it starts on Monday or Sunday or Tuesday or whatever. But if you find that you're constantly, in your application, you always start on Monday. Instead of always having to declare that object, you can say datepicker.myapp equals the old one extended with just this option set to Monday instead of Sunday or whatever.
It's like currying for classes.
Yeah, curry. I haven't thought of that, currying for classes. Anyone else? Time's a little low. Thank you for listening. I appreciate it.